Hello students, welcome to the interesting chemistry where you will enjoy a classroom teaching experience. Today I am going to explain you some numericals which are based on chemical equations. So these are the 5 numericals 1, 2, 3. I will solve this or I will explain these numericals one by one. So let's start the video to take the question first. Question first is, when KNO3 is heated, it decomposes into potassium nitrite and oxygen. So the question is asked, calculate the amount of KNO3, to get 1362 milliliter of oxygen at STP. So the amount is to be taken of potassium nitrate. What amount of potassium nitrate is to be taken to get the 1362 milliliter of oxygen? So first of all, you should write the balanced chemical equation. So first I am writing here the 2KNO3 2KNO2 plus O2. This equation, the stoichiometry of this equation is 2 mole of potassium nitrate. When heated, it gives or it produces 1 mole of oxygen. And you know the volume of 1 mole of oxygen at STP is 22.7 liter on STP. It's well-known fact. So now you require 1362 milliliter. So you can write here 22.7 liter of oxygen is produced by 2 mole of potassium nitrate. You can write here 2 moles, but in question you have been asked the amount of KNO3. So again, 2 mole of KNO3, the 1 mole of KNO3, 1 mole KNO3 is equal to potassium 39, N14, oxygen 14, oxygen 3, 48. So it is equal to 101 gram. So 1 mole of KNO3 is equal to 101 gram, 101 gram. So here 2 moles of KNO3 is required. So you can write here directly 202 gram KNO3 is required. So again I am telling you, to 22.7 liter of oxygen is produced by 202 gram of KNO3. So again you can write here 1202 upon 22.7 liter. So your requirement is 1362. So 1362. These are the this is liter and this is milliliter. So you can change it by dividing 1000. This is 1000 liter is equal to, so again 202 upon 1362 upon 1000. 1000. This is the amount which will produce 1362 milliliter of oxygen at STP. So you can calculate it easily. you can write here 3622.7. So you can write here 10 multiplied, so it will is by 6 and 12, 6 into 2, 12 by 100, you can write here 12.12 gram of KNO3 is needed to get 1362 milliliter of oxygen at STP. I think that you have understood the first question. It's very simple. So now come to the second question. Second question is, when calcium carbonate or limestone is treated with HCl, it produces calcium chloride plus 2H2O plus carbon dioxide. This is the reaction. So calculate the amount of HCl to react with, you can write here 40 grams. 40 grams of calcium carbonate. If the mass percentage of HCl is 20. So first, solve this problem up to here to get the amount of HCl with 40 gram of calcium carbonate. So first of all, you have to write the balanced chemical equation. So here is your balanced chemical equation, CaCO3 plus 2HCl is equal to CaCl2 plus H2O plus CO2. It is your balanced equation. So this equation. Now find out the stoichiometry of this equation. Here 1 mole of CaCO3 reacts with 2 mole of HCl. It is the case. Here only your HCl and calcium carbonate. So again the amount of calcium carbonate is 40. So you can change this mole into gram, into amount in gram. So 1 mole calcium carbonate is equal to 100 gram. You can write here 40 plus 12 plus 48. Atomic mass of calcium is 40, carbon is 12, oxygen is 16, 3. So this is equal to 100 gram of calcium carbonate. Now again, the amount of calcium, the amount of HCl, you want to know, you want to calculate the amount of HCl. So again, 1 mole of HCl is equal to 1 plus 35.5, because the atomic mass of hydrogen 1 and 35, so I think that it is 36.5. So 2 into 36.5 is equal to 73. From this equation tells us that 100 gram of calcium carbonate requires to react with it 73 gram of HCl, and you have to calculate the amount of HCl. So again you will write here 100 gram of CaCO3 reacts with or requires to react or reacts with 73 gram of HCl. Here, this equation, the balanced equation tells us that 100 gram of HCl reacts with 73 gram of HCl. So, what amount do you have? You have only 40 grams. So, calculate about the 40 gram. 1 is equal to 73 and 400 upon 40 into 40. So, you can calculate 10 and 40, 12 and 4, 7, 28, 28 and 29.2 gram. So it is the actual amount of HCl you need to react with 40 gram of calcium carbonate. Now come to the second part. If the mass percentage of HCl is 20%, what do you mean by it? It means the 100-gram solution, if the 100-gram solution of HCl contains only 20 gram of HCl. It means the composition of the HCl solution is 20 plus 80, 20 gram HCl and 80 gram water. So here again you will take like this, that the mass of HCl solution is 100 gram and the mass of HCl in this solution is 20 gram. This is the fact. This tells us if the mass percentage of HCl is 20%. It is the mass percentage. So the 100 gram of solution, 100 gram HCl solution contains 20 gram sugar. We have to calculate the amount of HCl. So again you will write here opposite. How will you write? That 20 gram HCl is 20 gram of HCl is present in 100 gram solution of HCl. 20 gram of HCl present in 100 gram solution of HCl. So again 1 upon 100 upon 20. And how much what is the amount, real amount to calculate the 40 gram, to react with 40 gram? So 29.2. You can write here 29.2. So the 29.2 gram of HCl will be present in 100 by 20 into this one. So you can calculate this 5 into 10, 0, 5, 9, 45, 46 and 5, 10, 146 gram will be your answer. 146 gram. In this way you can calculate. I think that you have understood about the second question. Now I am coming to the third question. The third question is Zn(H2SO4) and Cu plus. Here in this the third question, the cupric oxide is reduced by hydrogen, and this hydrogen, the source of this hydrogen, the source of production of this hydrogen is Zn plus H2SO4 ZnH2. So calculate the amount of Zn to reduce 15.9 gram of CuO. So first of all you should write the balance equation. So here you can write here that Zn plus H2SO4 ZnSO4 plus H2. This is the reaction. And CuO plus H2, Cu is reduced in Cu plus H2O. Now question is that this CuO is reduced. So first of all write the stoichiometric. Here 1 mole of CuO is reduced by 1 mole of hydrogen, and this 1 mole of hydrogen can be produced by 1 mole of zinc. Or in other way you can say, then when 1 mole of H2SO4 is reacted with H2SO4, then 1 mole of hydrogen is produced. So from 1 mole of zinc we can get 1 mole of hydrogen. This 1 mole of hydrogen is sufficient or is enough to reduce the 1 mole of cupric oxide. So directly this zinc is related to the reduction of this 1 mole of the zinc. So here from this you can establish a relation that the 1 mole of CuO is reduced by 1 mole of Zn. From this calculation, this stoichiometry tells us the 1 mole of CuO. The 1 mole of CuO requires 1 mole of hydrogen to reduce. So this 1 mole of hydrogen can be produced by the 1 mole of zinc. So this 1 mole of zinc is responsible to reduce, is enough to reduce this Cu, because this 1 mole produces an amount of hydrogen which is sufficient to reduce the CuO. So you can directly relate the 1 mole of CuO is can be reduced by 1 mole of zinc. So again here this is in gram and this is the amount. So again you can write CuO, 1 mole of CuO is equal to 63.5 plus 16, so it is 79.5. So you can write here 79.5 gram CuO is reduced by 1 mole of zinc. Zinc is equal to 65, so you can write here 65 gram. So in this way, because you have to answer here, the amount is given to in grams of CuO and the amount of Zn is to be calculated in gram. So you write here 79.5 gram of CuO, that is equal to 1 mole, and this is also equal to 1 mole. So again you can write here 65 upon 79.5, 79, and what is the amount of CuO? It is 15.9. So it can be your answer. So I think that you can relate it here, and this will, you will divide by the 5, and only 13 gram of zinc is needed to reduce the 59 gram of, it will be your answer. I think that the third question, you have understood about the third question. Now I am coming to the fourth question. Here in the fourth question is calculate the amount of the replaced iodine if the amount of MnO2 is 74.5 grams. So the potassium iodide, from this, the potassium iodide, we have a solution of potassium iodide, and when we pass the chlorine in the solution of potassium iodide, this will be, the equation will be KCl plus iodine. This iodine is replaced from this by the chlorine, and this chlorine is produced by, or can be prepared from MnO2 plus 4HCl. 4HCl is equal to MnO2 plus 2H2O plus Cl2. These are the two equations. First of all, you have to write the balanced equation, then find out the stoichiometry, then establish the relation according to your requirement as you are asked in your question. So here 1 mole of MnO2, 1 mole of MnO2 produces 1 mole of Cl2, and this 1 mole of Cl2 is sufficient to replace the, from the 2 mole, don't take it, what is this 1 mole replaces iodine is equal to 1 mole. So again, establish a relation according as you are required to calculate the amount of gram MnO2. This MnO2 is given here amount, and the replace. So it is the given amount and you have to find out the amount of iodine. So how will you establish the relation between MnO2 and I2? So here MnO2 when reacts with HCl, it produces chlorine, Cl2. So 1 mole of MnO2 produces 1 mole of Cl2, and this 1 mole Ca2 is sufficient to replace the 1 mole of iodine. So again, the chlorine which is produced by 1 mole MnO2 is sufficient to replace the 1 mole of iodine. So you can write here 1 mole MnO2 is sufficient to replace the 1 mole of iodine, 1 mole of iodine, or you can write the 1 mole of MnO2 produced sufficient chlorine to replace the 1 mole of iodine. Again, now here again the amount is given in gram, so you have to calculate the 1 mole of MnO2 into gram. Mn is equal to 55 and O2 is equal to you can write 32, so it is 87 gram. And 1 mole of iodine, I2, I is equal to 127, so it is equal to 254 gram. So again come here that 87 gram of MnO2 is required to replace 25 gram. So directly you can say the MnO2 replaces 24 gram of iodine. So again, so 1 here 254 upon 87. And what amount of MnO2 is given? 17.4 gram. 17.4 gram. You can write here 17.4 gram. So again, you can write here 10, 17, 2, and 20. Oh yes, 2, 8, and 50. So here 508 upon 10. So you can write here 50.8 gram of iodine will be replaced from this question, from this MnO2, 17 gram of the MnO2. I think that you have understood about the fourth question. Now I am coming to the last, the final question, that is the fifth question. In the fifth question, when 1 liter of H2S and 1 liter of SO2 on at STP, the volume of both the gases is on at STP. So 1 liter is at STP and 1 liter of SO2. So here again H2S and this is SO2. The reaction between the H2S and SO2. So write the first balanced equation. So what is the balanced equation? It will be 2H2O plus 3S. Both the reactants will reduce each other. H2S is also reduced and SO2 is also reduced. So it's the H2O. So this 3S is formed. So again come here. Find out the limiting reagent. One thing, limiting reagent and the amount of S is formed. There are two questions. First you have to decide which one is the limiting reagent, whether H2S or SO2. One thing. Second one, the amount of S that is formed. So the amount of S that is formed in this equation is dependent on the limiting reagent, because limiting reagent consumed first, and after that the reaction won't take place. So this sulfur is dependent, the formation of the sulfur, the production of the sulfur is totally dependent on the limiting reagent. So first of all, decide the limiting reagent. So here in this case, 2 mole of H2S, 2 mole of H2S reacts with 1 mole of SO2. So the ratio of this is the volume, 1 mole. Suppose you can write here 2 into 220.7 liter at STP, and 1 into 222.7 liter at STP. So the volume, the ratio of the volume is 2:1. The H2S and SO2 reacts with the, so this volume must be in 2:1, but it is in 1:1. So you can write here the 2 mole, or you can write 2 volume of H2S reacts with 1 volume of SO2. So the 1 volume of H2S will react with half volume of H2S. So you will write here, what is the volume of H2S here? 1 liter. You can write here 1 liter or 1000 milliliter. You can write here. So the 1/2 into 1000. So 500 milliliter. So in the last, this is the amount of H2S, this is the amount of SO2, and this is the, so 100 milliliter of H2S will react with 500 milliliter of SO2. So which compound or reactant consumed first? So here we have only 500 1000 milliliter H2S, and here 500 milliliter of SO2 plus 500 milliliter of SO2. So it will be react with this 700, and this will be remain unreacted. 500 milliliter of SO2 remains unreacted in this reaction, and this H2S consumed first. So the H2S is the limiting reagent in this numerically in this case. So I think that you have understood how will you decide the limiting reagent. If you decide the limiting reagent, then you can calculate the, oh now there are two reactants, this one and this one. So as the limiting reagent is H2S, so the calculation of the amount of sulfur will be done by the limiting reagent. So we will write here 2 mole of H2S produces 3 mole of S. Again it is that. So again here what amount of the H2S is given in liter. H2S is given in liter. So you can write here 2 mole. The H2S, the volume of H2S at STP about the 1 mole is 22.7. So the 2 into mole, it is the liter. Volume at STP gives 3 mole of sulfur. 3 into mole. The S is equal to 32. The molar mass of sulfur is 32, or the atomic mass of sulfur is 32. So the 1 mole you can write here 32 is equal to 96. See again, it means for fairly I will do here that you can write here that 2 into 22.7 liter of S2S produces 96 gram of sulfur. From this calculation, I have told you in this here, this calculation tells us. So, for 1 liter, you write here 96 upon 2 into 22.7. And what the volume of the S2S is given? The 1 liter. You can write here from 1 liter. It is only 1 liter. So it is, this is 2 liter, it is 1 liter. 2 point is 112 liter. So again, you can write here only 1. So again, you will write here 48. And by this calculation, what amount of the sulfur is given to here, that will be your answer. I think that you have understood. Please calculate it. I am not going to calculate and get to give you the final answer of this question. So please calculate it. So I have told you the 5 numericals. This 5 numerical will enhance your understanding about the numericals based on the chemical equation or about the stoichiometry of the balanced chemical equations. So now at the last, I'll say to you that please like it, share it and subscribe it. If you will subscribe this video, then the notification of my coming video will automatically come to you. So that's all for today. Thank you very much.